Yeah, I can see it. But this one might be there we go. Is Drew in the room? Yes, he is. Okay. We're going to go ahead and get started. Drew, do you want to say a few words? You sent me an email that there's going to be some remote attendees. Yes. Okay.
Come to the mic.
Yeah, come to the mic. Before, one thing. Everybody, have you seen the note wells? Any IPR you know about you're participating in this discussion, or even if you're not participating, you're required to disclose it.
Hi, I'm Dhruv from Huawei. So in association with ISOC Bangalore, Huawei is hosting a remote hub, and we did it yesterday for PC working group session. Today we have for OSPF and the plenary afterwards. So our aim was to get a bunch of vendors who are anyway there in Bangalore, but who had no opportunity to come to the IETF, who have worked on OSPF or interested in OSPF protocol, to get in the same room, go over the agenda beforehand, look at how the working group progresses, and later on, once the working group is over, discuss what they've learned, if they have any questions, how do they post the questions, what are the process in which the IETF works. So apart from the vendors, we also had some university students who are interested in this process. So it's going to be a good experiment, and we'll get back to the working group based on the feedback that we are getting. And this is something that anyway IETF is interested in. Tomorrow morning, there is a barb-off on how to conduct remote hubs and how can we make this process go smoother. So we'll be sharing each other's experiences of various places like in Latin America and in India, where this experiment is already started. Thank you. So please say your name on the mic more clearly this time. Thank you.
Is there video being projected too with this camera?
No, not the radio.
Oh, okay, just audio. Okay. Any questions on the note well? Okay. With that, I'll turn it over to Ave. We probably will not take the whole 2 hours. I looked at sort of all the presentations. So there's time for karaoke later. But it will have to be a cappella karaoke. Oh yeah.
You do realize what oxymoron?
Yes, I do.
Okay, next slide. Just the working group status. I'm going to go over. You want to go slideshow?
Okay. I'm not. That's the problem with the.
We'll go full screen. That's fine. Just go full screen. Just go view full screen. That's enough.
Okay.
And then you can scroll from the.
Still.
You could do this for pages.
Yeah, that's okay. That works. So
Okay.
we can still go from PDF.
So RFCs, we don't have any since Prague. We are very close on the couple. If you can go to the next slide. So 4970 BIS was to allow for multiple RILSA instances. That is in RFC editor's queue. OSPF v2 prefix link attributes is also pretty much done, sitting in RFC editor queue at this point. Node admin tag had a lot of discuss from IESG. The good news is all of this is cleared, so it should pretty much get pushed out of IESG soon. SBFD, we finished working group last call. AC had an open question end of last month. We need to nudge the authors to answer on that. And after that, we can request for publication. Yeah, so these are the two which are very close to the last call. tardiness on our part. There were a lot of other things we were trying to push, but we're pretty much going to push this. First one is for use cases where the devices don't have IPv6 capability at all. So it's a very simple draft. The two-part metric is also pretty simple, has had a lot of discussion. I think I saw Jeffrey in the room. There was one minor edit I asked Jeffrey and he agreed. So we'll do that and you can last call that document.
There was one other, Shadra had a comment that we should clarify how to handle, at least specify what we do in stub for the stub router or the stub router case.
Okay. The active documents, actually you will see presentation on most of this today. OSPF v3 extended LSA, AC respun this with the new concept of sparse mode, which is basically to simplify the migration. You don't have to worry about the old versus new, and you can only, again, I'll let AC do more justice to that. Segment routing drafts also have updates today. The V2 one has some conflict resolution updates. And we also have update on the Yang model direct. Other active documents, these are, so first one, MRT is basically waiting for movement on the routing working group. Once that happens, we will also move. It is currently accepted working group document. The TTZ we accepted as experimental. We haven't had a lot of discussion. So we would love to have some more discussion on the working group and then we can last call that document. Next. FlowSpec was presented, I think, a couple of IETFs ago. There were two competing versions. We merged them into one. We have some prototypes coming along, so we can probably share some news on that in the mailing list. Entropy level is also, it's waiting on the MPLS working group to proceed further, and we'll progress that document.
That one is actually close to expired. Are any of the authors in here?
I think it is expired.
It did expire, okay. So I mean, I guess it's not that important if they're not pinging us on it.
Okay, and we accepted a bunch of new documents. First one is link overload. A lot of passionate discussion on the mailing list if you have been following in the last month. HBit is the host bit, which is opposite of OSPF v3 router bit. So that also got accepted. Encapsulation capabilities is all sorts of tunneling, which we're trying to do. It captures in our ILSA what encapsulations you support. So these are all new working group documents. There are some other documents progressing in other working groups. We actually had a discussion on the beer, for example, where we agreed that we will progress it in the beer working group because the OSPF changes are small. Beer is still going through some major architectural stuff. So that will progress there. And there are some documents sitting in CCamp, again, with our agreement from that. I think that's pretty much it. The next up is AC. AC did a major recharter updates. We have not updated our charter for a long time. Alia is in the room. So we finished that. We have good milestones for them. Again, I'll let AC talk to it.
Okay. I know that the charter is written in such a way that it is self-perpetuating, and I don't see any need to make it too specific. So what I actually did is I actually took all the work we finished and marked it done, and including stuff that was started and finished before it even hit a milestone. So I got us back to the future in that and added the new stuff we're doing. Basically, we have 4 tracks, a little bit more. We have, well, 4 tracks. And I think I put these are things I put into the charter. The things that aren't done are all part of these 4 tracks. Let me go through what they are. Basically, they're the protocol extensions using TLVs. We're pretty close to that with OSPF v2. That's on the, I mean, we're actually done with it. It's in the RFC queue. And we probably won't need to do any more of that. OSPF v3, I've got a presentation today where I've simplified it, more or less given an option that doesn't have any backward compatibility implications other than the implications for the functions that use that. Now, the second track, after the extensions are applications that make use of the new TLVs or the RFC 4970, the router OSPF router information LSAs. You know, those are for both. And these are generally all these applications are applicable across both OSPF v2 and OSPF v3. This would be the place where, if we did ever have an overlapping part of our meeting with ISIS, this applications area tends to be pretty standard between the, I should say, between the three protocols, because we have OSPF v2, OSPF v3, and ISIS. And finally, we have protocol enhancements. These are, you know, little, you know, big or little or big optimizations, changes like the experimental TTZ, or small ones like what we did with the Monet enhancement to the database exchange, things like that, you know, things that actually affect the protocol mechanics of OSPF. The draft you're going to see from Padma, the stub neighbor, this would fit kind of in a, I would say, in a medium size. It's not a small enhancement, but not as cataclysmic as TTZ. Maybe that was the wrong adjective, but not as not as big as TTZ. Okay, you know, and then we have security. We're done for now, but I'm sure there'll be additional requirements, additional things for now. We have completed all the drafts to support the CARP requirements for manual keying. So I think we're pretty much done. You know, there's a lot of other considerations. The IEV focus on privacy. Maybe we'll have to have encryption. We'll have to figure that out for multicast. I don't know, key, which would include something to do multicast key distribution. I guess it wouldn't have to, but that's another one. You know, that there was always this discussion about whether, now that we have manual key distribution, would we do something for automated key distribution as well? And then the final track is manageability, and I think we have the Yang model. I think that's about it for now. There might be, I mean, I'm sure there'll be augmentations to that as well, and that's it. I'm going to go again. I'm going to talk about extended LSAs. Okay, here's where we are. The draft has been pretty stable. We got some good reviews out of people like David. I saw he walked in, and it seems like it's really ready. I mean, seemed like it was pretty well baked. Even we. A couple of us have even looked at what it would take to implement it, and there are still no implementations, which is unfortunate. So even though they're required, these extensions are required for segment routing. And when I looked at it, and we looked at what it would take to do it, the big barrier in terms of it seems to be the migration, because the migration is quite complicated with the three-step process. So what I did in this version is something people wanted. Well, here's the previous migration paths. Of course, you could do a greenfield network. You could just come in with the extended LSAs. Or if you have, like they do, used to be in the old days, before 24/7, where they used to have maintenance windows, and they migrate the whole network over a 6-7 hour period. You don't see a lot of that. Then there's the same way that you could do it with multiple instances, where you just use the route preference or admin distance to bring up the two instances, bring up this extended LSAs with the higher preference or distance, which means less preferred in this case, both for preference and admin distance, depending on your platform. And then once you verified that the migration has taken place successfully, you switch over to the new LSAs. You lower the preference and you install routes based on the new LSAs. Then you can take off the configuration of the instance that you're trying to migrate from. So
And similarly, the draft includes a single instance approach to this, where you advertise both the extended LSAs and the existing LSAs, but you're still using the SPF. I mean, you're still using the existing LSAs, the legacy, let's call them legacy LSAs. That's what I call them in this for the SPF. Then you switch over to use the extended LSAs for the SPF, make sure everything works, and finally you purge the legacy LSAs. And that step, I think that's the place that people, you know, it sounds simple, but you know, there's a lot of devil in the details, and it is, if you know how people test things, it's really a vector that you can really hit it hard and come up with a lot of hard cases to make work right. So what I added is a new mode. It's the sparse mode. And basically what it is you're always using the legacy LSAs. And what you do is you use the extended LSAs only for the new functions. And backward compatibility is the responsibility of whatever function it is. You know, just like in segment routing, we have to cover backward compatibility or whatever ones. So you only need to include the TLVs that are necessary for these new functions. So if you have a link that doesn't have any requirements for the new functions, it wouldn't need to exist in the extended OSPF extended router LSA. So basically what we've done is we've just taken what we did for OSPF v2 and we're doing it for OSPF v3, only it's a little cleaner here because we have a separate LSA type for each of the existing LSAs. Oh, and if you're familiar with this draft, if you're thinking about it, you know that the OSPF v3 options are used to say what stage of migration you're in for the 3-step migration. In this case, if you're just using these for new functions, it's essentially you're in the initial state where you're not doing migration at all because you're just using these new LSAs for new functions. Compliance, you could implement just the sparse mode. This is to try and make sure that this migration is not a implementation barrier or adoption barrier. Or you could implement the full support and the sparse mode. Or you could do the whole ball of wax. You could do the full mode, all 3 steps in the migration, and the minimum. You always have to do the sparse mode for new functions. Now, what I'd like to do is since I don't see, what I'd like to do is just take this complicated mode where you do it with one instance, and I'd almost like to deprecate it. It's not really very, I don't know if you need to call it deprecated because nobody's implemented it, but I'd like to take it out of the draft. Why do I keep doing that? Here, I already went through this, the complexity. Obviously, because we don't have implementations after 2 years, it's represented a barrier. And the other thing is the multiple instance route, you know, the other route to have an instance generating the old LSAs and one generating the new LSAs. That's kind of well understood because that's what you do anytime you're migrating between, say you want to migrate your network from OSPF, from ISIS to OSPF, you would do the same thing. So it's pretty well understood. And really by doing it in a single instance, you're really not saving yourself that much. You know, implementing this complex because OSPF is IO bound. So, and most of it's, you know, flooding is responsible for most of the scaling issues. So an integrated migration, in my opinion, it doesn't save that much over the 2 instances. There's another reason too. It actually, if you do separate instances, you actually have better isolation between the process or the OSPF instance running the originating the legacy LSAs and the OSPF instance originating the extended LSAs, because both are running SPFs independently, and they both have their own local rib. So you can really verify that they're getting the same things before you and look at them. Whereas in the case where you just switch over, you don't know, you're doing a leap of faith that it's gonna, you know, it's gonna have the same results. Now, in some platforms, if you do separate instances, you even get them in separate processes. So you're actually getting better scaling because you're spreading the load over more processes, and just because of scheduling and the reality of how things are implemented, it's gonna be possibly even less of a load with multiple instances. And like I'm saying, there's less chance of bugs because, you know, this code is only going to be implemented. It's not going to be executed many times. A person would only do this migration once, unless they were unsuccessful. So that's all. So any views on this about going to the sparse? I think the sparse mode is something we're going to add. But any views about getting rid of the more complicated migration and just going with the full, and possibly, you know, because this draft's been so stable and I just put a little line about what I did, you may not have read it anyway, so we can discuss it on the list. Okay?
Anybody hasn't shined the blue sheet?
Or I'll just change it. Oh. Okay. Peter just spent, I'm gonna present these slides for Peter. He just spent two weeks in Bangalore, so he wasn't interested in traveling around the world again so soon. So he made these slides, and you can see the other contributors on the segment routing. That's going quite well. Okay, the SR OSPF segment routing. It's been basically, you can read this. It's been presented at multiple IETFs. There's been multiple vendor implementations and some interop testing. So it's going along quite well. I think we would have working group last called it by now had we not tweaked some things, both in the, you know, in the encodings over the last year and a half. This is making use of the prefix linked attributes OSPF v2 draft that's currently on the RFC editor's queue. I guess I already said all these things. Yeah, no changes. I guess we're going to do a good review on it, and hopefully I'm not an author, but I'll review it as well. And then I'd encourage everybody else to read it, because this is quite, I mean, this is pretty much implemented by all the major vendors. Now, one thing that's happened is we've had a lot of discussion on what to do if you get complexing information, especially with respect to a mapping server, because with a mapping server, you can have multiple guys advertising the same prefix, and how to resolve conflicts. That discussion, there was a long discussion on the ISIS list, and we're kind of waiting for that to coalesce. And Les Ginsberg was good enough to put some ideas in a draft, and we've started a discussion in spring on how we're going to get everyone to agree how we resolve conflicts when they're, especially when different routers are advertising the same prefix with different segment IDs. You know, the SID, if you recall from segment routing, node SIDs and prefix SIDs are globally should be globally consistent within a routing domain. And finally, one thing for the prefix SID, prefix linked attributes draft, we had some early allocations for the for this draft, the segment routing, we had early allocations for the OSPF router information LSA, but we didn't have them for the prefix link attributes because that was a draft itself. So those registries hadn't been created, but now they've been created due to the
the draft advancing. So we got early allocations of these. There are some other applications based on prefix linked attributes that are also going to request early allocation. I think we'll do that so we can just keep those things, keep people implementing on top of that. And again, we're hopefully we'll get a good review of it and work with class call of it. This is, nobody's implemented this that I know about. I'm hoping now that I have the sparse mode, it will do some, it'll motivate people to implement the OSPF v3 segment routing draft. There was one open source implementation in, I think it was in Budapest. I don't remember the name of it right off the top of my head, but we'd exchanged some emails. So I'm going to try and see if now that we have the sparse mode for the extended LSAs, I'm going to ping them and see if they'll kind of kick it off and shame the vendors into implementing it. And that's it for Peter's slides. Anybody want to say anything about segment routing? Oh.
No, just the standard note to last call it in the spring also, so that they know it's happening.
Oh, yes. Okay. Yes, for the OSPF v2, we'll do that. We're sort of, although it's not, I'll say one more thing about that. Although it's not necessary because we've taken that conflict resolution out into a separate draft, I think it would be not necessarily have that draft, have all the people that discussion over and make sure that, you know, we've incorporated that into our implementations, and that would demonstrate that it was sound. Okay, who's next? Derek? Yes. The squares are bigger this time. I guess they figured IETFers weren't coordinated enough to stay in those little squares.
Okay, testing. Okay, I'm Derek Yale from Cisco Systems. I'm here to present update for the 03 YAM model for OSPF on behalf of other co-authors of the draft and also other co-authors on the model itself. Next slide, please. So agenda, we'll tell you that we'll talk about a change we make from different from 01 for the base model, and also the different for the SR model from 01. And we this time add a new OSPF BFD module, and we'll talk about some next steps. You may ask why we are presenting 03, but we are comparing 01. Actually, when the issue is that when we submit 01, I make a prior mistake, and so that expired in September. So I just need to submit 02 to extend that. So that's not much different in 01 and 02 other than on tutorial. Next one, please. So for the base model, now we add Helen as the co-author of the base model. Thanks for her continued support and comment and everything. And so we don't have a lot of change this time. It's basically what we have here. The first change we make is that before we have actually 3 identity. We have OSPF, and from OSPF we derive OSPF v2 and v3. We think it's nice because now we can use some trick to reference both OSPF v2 and v3 as OSPF. But it turned out that when people implement it, because they have no idea that you are supposed to instantiate just OSPF v2 or OSPF v3 type, but not OSPF type. So they do have cause some confusion. So after some discussion, we decide to just remove the intermediate one, just have OSPF v2 and v3 instead. Also, another change we make is that the area ID type, we have a union before, and it supports both the 32-bit numbers and $quad. And after some discussion, we think that so first, not all implementations support both, and the MIPS only support $quad. So after some discussion, we decided to just keep $quad also, and so now left to the management station. They can get $quad if they want to change it to 32-bit for representation. It's done by the management station rather than in the backend implementation anymore. And do some correction about the area ID type, because before we also have some incorrect, some mistake there. sometimes we use explicit dollar quad or explicit UN32, but now we change all to the standard area ID type, which map to a dollar quad. And because we have the other things that we have a new BFD YANG model submitted in last IETF. So because of that, they define some grouping. So to accommodate that, we move our BFD support in the base model into its new module. This in order to avoid anyone that just use IETF OSPF module, which if it's forced to import BFD module, then they all need to do it all the time, even if the platform, say a low-end platform, doesn't support BFD. So by moving it to another module, then we solve the problem. So if they support BFD, they include OSPF BFD module that include the reference to the BFD module. And then we also do some restructuring of the notifications. And I will go through that next slide.
I just got one thing to say about the area type. Most implementations support either a number or a dotted quad in the CLI, but since this is a programmatic interface, we thought, well, we might as well just pick one, and makes it a lot simpler, and doesn't require us to keep which one the person, which one it was configured in. As a matter of fact, I know that most implementations support multiple, both ways to do it, but I only know of one that actually saves which one was done and tries to show it that way in the displays.
Okay, so when we first do the notification, we basically go through all the MIPS traps, and we just map it out and define a YANG model. Now we have time to go through it. We actually identify that there's some we can rewrite in some way to make it more clear. So now all the notification basically contain some standard part. So we always have a notification header. Instant header tell you which instant OSPF that generate the trap or the notification. And then we have another grouping to say that which interface is generating the trap. And then we have another grouping for which neighbor is doing that. And then, of course, each notification have some notification specific field in the notification. Next one, for example. So here I just show you an example that we have interface state change notification and neighbor state change notification. You see the blue part, they all share the routing instant header to indicate which instant is coming from. And then we have the red part that tell you what type of interface, virtual link, normal interface, sham link. And for the interface state change, that's it. Then you also need to stay for the interface there also. But for a neighbor state change notification, we also have that neighbor state grouping that you can have the neighbor information and then follow with its own state information. So all the other, it's just two examples, but all the other notification now follow the similar way. So it's more structured. We also clean up some of the header before. Say, for example, insert link selection type before we can. Technically, you can have both. You can generate notification with same interface, virtual link, and sharing together. But right now, I make the choice so that it's more correct. Next one, please. Okay, now OSPF SR. So in last IETF for the spring meeting, there's discussion going on for the need of per protocol sRGB block. So and afterward they make the change. So in the YANG model to support the per protocol sRGB. So we make the change accordingly in our SR model. We basically add a new block, container protocol sRGB under the instance containers. And it's a feature, so if protocol sRGB, which also define SR, is there, then we will have the list of sRGB grouping, which define the SR model also. And the left side is what we write in the YANG model. The right side is what compile out as a tree. Okay, next one. So OSPF BFD. So it is similar to SR that it's a new module, but it's in the same OSPF YANG draft document. We create both operating state and config state for the BFD. The major thing that now we need to use the grouping from BFD is that they also before we can config BFD on or off on the interface. In the BFD draft, YANG draft, they also allow per protocol configuration and have some grouping. So that's why we need to make use of their grouping, and if we make use of their grouping, we need to import their module. So that and doing that create dependency. So that's why I moved the dependency to this own new module. Next one. So this is again what we have done. So we add a BFD containers in OSPF. We still have enable flags, but now if we have the BFD protocol program features enabled, then we'll also use the groupings in the BFD, which allow us to also configure, say, as you see here, the TX interval, RX interval in the per protocol basis or multiplier. Okay.
Yeah, this was AC Lindum. This was just sort of a discussion with the BFD module too, whether or not you'd configure these things within under BFD for the interfaces, or whether some a lot of implementations had them in the protocols. So this was a compromise. You can, if you have this feature, you can do it either way.
Yeah. So right now we create a whole we create our own container and use the BFD grouping. But if you look at BFD Yang model, they actually have another grouping, but we cannot use it because if we use it that way, we cannot control whether BFD is enabled or not by itself. So if they make a change, maybe we will just make use of the new groupings. But right now, that's what we have.
Okay.
Next one, please. So next steps. So what we are looking at is more information efforts. So if anyone know of any vendor is doing implementation, it's good to know so that we can talk about that and try to see if we can test it out, see how it works. And from the model point of view, is from last IETF, it's pretty stable. We're looking at do we need to add more state, and we look at policy actually, and it turned out the policy draft there's some from my point of view, there's some issue there. It doesn't specify the you can redistribute from OSPF protocol, but you don't know which instance, so we need to fix it first. So we need to talk to them, and when they are ready, then we could make use of that and add the redistribution and the policy-related things in OSPF. Another thing we didn't get to do is we want to do is have the inheritance container and the content more complete. Right now, we just have a container. We want to standardize on as a features when you want inheritance. How does it work? And we also get some new requests about adding things to the OSPF model. Just before IETF, I think people asking whether we should add MTR, MLT, and also whether we should add the NOC and min tag. So we'll look at it after we go back after this IETF, either as a feature or module. We need to know what we'll figure it out. And so what the other thing that could affect our model is the operating states payment. Today in that model group, there's some talk about what it should be. Do they do data store or use the OC model? So we'll check to see whether we would have a consensus and see if it's close or we still need to do something. And of course, we also looking for big feedbacks. Actually, we saw some feedback from Alan in the mailing list, and we are going to reply to that. Any question?
That's Alan Davey from Metaswitch, yeah.
Okay, thank you.
I just wanted to, AC Lindum again, I'd want to encourage people to review and comment on the policy model in the routing working group, because we're kind of looking at, I've been in discussions with my comments and see if some of you come up with the same comments independently. Padma.
Padma Place now from Cisco Systems. I'm presenting today the scalable hub and spoke on behalf of my co-authors. Next slide, please. The draft was previously presented in our IETF in Dallas, and this new iteration is actually to address the working group comments. The two major areas were one, to detect misconfiguration, And the other one was clarification on the flooding and handling of the local router LSA. All right, what are we trying to solve first? So in one level hub and spoke topologies, usually the spokes only exit is through the hubs. And as such, they are usually leaves, and they do not need to know the whole topology behind the hub. Secondly, usually the spokes have limited capacity. So they are actually storing a lot of information which is actually unnecessary for them. From the hub's perspective, handling a flooding of large database to each one of the spokes actually limits the amount of spokes you can actually handle. And today in OSPF, there is no mechanism to aggregate intra-area routes or even filter them. Next. The proposal is, number one, we're going to use the stub neighbor functionality, what we call the stub neighbor functionality, to make the hub routers aware of each other. The hub routers will define a new type of neighbor relationship with their spoke and actually send them a modified router, let's say, with limited information, just enough for what they need to actually forward their traffic. And we will see a little bit more about what this modified form of the router LSA is. For now, the router LSA, the local router LSA, as I call it, is going to have a default route, which enables the hub, the spokes, to transit this traffic.
Next. Yeah.
All right. Here's the format of the local hub router LSA. The blue box here is actually what's different. As you can see, we have a link ID with a default prefix, which will actually enable the spoke routers to install an intra-area default route, which it couldn't do before. All right. Regarding handling the router LSAs, one of the major issues that was raised before is how do we separate the normal router LSA as we know it today and this local router LSA, that it doesn't get leaked out to the normal OSPF. So if you look at the slides, we have two zones. We have a zone with all the stub, what we call the stub links, which are actually the hubs and their spokes. And the rest of the OSPF networks are actually the normal links. So for this draft, what we're proposing is actually to change only the hub. We do not have to upgrade the spokes, but the hubs have to be upgraded in such a way to actually create that boundary. Next slide. So the local router LSAs are going to be flooded on the stub link zones to the spokes. And a hub receiving its own local router LSA not on a stub link zone actually can detect a misconfiguration and act upon it. That could be by policy. Either we can actually revert back to the normal OSPF process or log an error. A hub receiving another hub's local router LSA can also act upon it if it receives it on a normal link, which means that would be a misconfiguration. However, if it receives it on a normal stub link, then you should just acknowledge it to make the adjacency come up, but it should not use it for its normal ISA. A hub should not actually receive the local router LSA on any other of its normal links. So I'm going to illustrate that in the next slide. So if you look at this example, imagine hub 2 using the green arrows is actually transmitting the normal router LSA as we know it. On its stub links to the spokes, he's actually sending the modified router LSA, which is the local one with the default prefix. The spokes on receiving it are going to reflood it just as normal OSPF process. However, if you look at hub 3, which was also upgraded, it will actually acknowledge it, but it will not forward flood it any further. However, if you look at the other case of maybe the hub 1, which is misconfigured, it will actually receive the local router LSA and try to reflood it back on its other links. Now, at this point, if the local router LSA was coming from hub 2, he can actually act upon it because it's its own router LSA, and he can detect that he got it over a normal link, and that signals a misconfiguration. And if this router LSA was actually coming from hub 3, hub 2 has the capability of now detecting it because it knows the other hub who are actually turning on this functionality.
Padma, is it AC Linda? Padma, is that that it receives the router information LSA or the router LSA over the backbone from someone else?
Router LSA over the backbone, but he
How-
already has the router information
Right,
LSA as well.
Okay. Okay. How would he know that it was a stub one? Because there's nothing to say that it's a stub one in the router LSA.
Actually, it has got the default route. That's why.
Oh, he checked for the default route. Okay,
Alright.
okay, yeah, okay,
Aggregated route.
okay. I guess that's it.
All right. So my co-authors and myself would like to request this to become a working group document. And as usual, comments are welcome, questions as well.
Philip Matthews, just a question. In your diagram, can your spokes be rings as opposed to you just show a single router, but could they actually be rings of routers?
Yeah, absolutely.
Yeah, it works as long as it's isolated. I mean, it's its own site, you know, and you define the links that go to it. As long.
Kevin Patel, Cisco. I have a quick question. What if the spoke at any given time wants a more specific route?
Wanted a more specific route. Actually, in the draft, we also actually enable policy to have aggregated routes as well.
Hi, Aaliyah Atlas, no hats. So I have two questions. One is, can you handle spoke-to-spoke links if they become necessary in this? Or one can have rings, but then sometimes you also end up with scenarios where, because of the quantity of traffic, that you want to be able to connect the two spokes just for particular routes.
Yes, I believe so.
Let me just. AC Lindum, you'd have to treat that as a single site from perspective of this function, because it's home to as many routers as many border routers as you want, but you'd have to treat it as a single site.
Okay, so you couldn't dynamically create and destroy them. Basically, you'd have a little bit more complexity there because of having to treat it as a single site. So you'd have to either change from treating it as a single site or not. It's a particular use case. And the other question, last IETF in our TGWG, Shad had presented about virtual multi-instance, which it feels to me, and I am afraid I haven't read your draft, I'm very sorry, that it's similar in terms of the problem it's trying to solve. So I'd be interested in your perspective on that offline if you haven't read it now.
Oh, definitely. I would love to do that.
Thanks.
Okay, how many have read it? I have read, of course. Yeah. Okay. How many people think this is a problem we should solve here? Assuming, I think so. I think it's a good one. Yeah. Right. Okay. So we'll take it to the list. There's one thing I wanted to say, and Aaliyah kind of hit on it too. And I'm going to take an action. I think I have IPR on this with a different company, my prior job. So I'll send. I think it may be IPR. I'm not going to make the judgment. It's close. It's again solving the same problem. I don't know if the mechanisms aren't close enough. We'll let them decide, right? So I'm going to take that action. I think there are other people that may have something close enough that you should also inform, see if your companies need to want or intend to disclose something on this. So that's what I'm saying. No, they aren't. No.
So AC, I think it might be worthwhile to mention that this IPR disclosure is an area where you make mistakes on the side of disclosing stuff too much
Yes.
rather than not enough.
Yeah, but since it's a prior company, they're going to have to make the decision as to whether they.
Right, but
Yes.
I'm not speaking to you personally. But
Up to the mic, please. We have
Right.
the folks. Up to use the mic.
Okay, so we'll take this discussion to the list about making a working group document. I think it's a good problem. Okay. What's that? I don't know. I'm not using PowerPoint, so I don't know how it. Oh, it does? Oh, okay. What would I have done during the working group if I didn't have to do this?
So I'm going to talk about the OSPF T-link attribute trees and use case and what we are trying to achieve here. And on behalf of co-authors, obviously. Next slide, please. So over the years, we've defined many link attributes to advertise some T attributes. We always use the sub-TIL with T-link TIL to advertise traffic engineering information. Next slide, please. So we've had many discussions on the list what exactly T topology is. And I think RFC 3630 is very clear. If link is described in T LSA, it is part of T topology. So it is there, it's written this way, and I think it's not really ambiguous to understand what it means. We had really many discussions on this.
So I don't think the discussion on the mailing list is resolved. And so we could continue to have it here, or we could continue to have it on the list or have it another place. But I don't agree with that assessment.
Okay, you're right.
That was Chris Bowers.
Juniper, yes.
Yeah.
Next slide, please. So thanks to new things coming up, we've got new unified container to advertise new link attributes, and it's progressing quite well. CC shared with us, it's getting to be published quite soon. So the important point, you don't have to make or don't make it part of T or HB topology. It's really up to receiver to decide. Next slide, please. So there are many different solutions or things we could use this information. The LFA is one come to mind, and we started the discussion about 3 years ago. How can we use information available today in T database for things like LFA, which doesn't use T topology at all? So finally, and what I'm presenting here is ability to copy these attributes we are interested in. The first coming to mind, obviously, SRLGs and indirectional delay, unidirectional jitter, this kind of parameters, and be able to use them to do some computation, which is not SPF in this case, not advising T. And this problem exists in many implementations I'm familiar with. So next slide, please. So the two solutions to that, one is to use T LSA. Another one is to use extended link LSAs and copy this information into them and then flood it separately. So here we are assessing the use of both. Next slide, please. So if we use T LSAs, the problem, even when T is not enabled, and in most implementations, it's explicit configuration, you need to configure it to work. If we start using T LSA, we explicitly make link part of T topology, while it might not be the intention. Number two, there's absolutely no way for OSPF to recognize whether advertisement has to be made part of TE topology or IGP. Next slide, please. So the option 2 is to use extended link LSA and copy case-by-case information from, or not to copy, flood this information in non-TE format. So this information could be flooded across the network and consumed by other routers without making them part of TE topology. Next slide, please. So the advantages are, you don't need to create TE topology if you don't need to. We don't touch T LSAs, so they're backwards compatible with 3630. And clear distinguish. If you look from operational perspective, it's always good to have clean distinguish between T and IGP databases. Ability to look into both without mixing. So we propose to use option 2, and again, there's been a lot of discussion among different vendors. I think there's a problem to solve, and the solutions, at least from my point of view as co-author, solves this problem in a good way. So comments?
Les Ginsberg. So I don't know whether I'm putting my own foot into the mud or something, but conceptually, ISIS has the same problem, and nobody's talking about doing this in ISIS, and so I'm wondering if we need to say, the two IGPs need to solve this in a similar way, because typically we're both talking to the same TE module
I
inside.
did talk to you about this. I didn't do it yet.
Yeah.
But essentially, yes, both IGPs have exactly the same problem. T database is different than IGP database. And
yeah, interestingly enough, I don't know that anybody has mentioned this in the context of ISIS. Perhaps because we just keep thinking, well, everything we do is a sub-TLV, and you can use a sub-TLV for whatever you want. We didn't have to invent a dedicated LSA, so.
Right. There's a much cleaner separation between the TE and non-TE information in OSPF.
Well, yeah, but the point is, okay, so right side of the room, left side of the room. But
he's abusing his chair.
Let's continue taking the notes, though.
Yeah, I'll remember this. Yes. But the point is, it's a single advertisement in both protocols, whatever the container is, and it's being sent to the same module inside the box, right? We're both talking to the same TE subsystem.
Okay.
Chris Bowers with Juniper. So I've made some pretty detailed comments on the list about this. The two main things are, in terms of the draft, actually, I still don't get a clear understanding of exactly what a TE application is or not. I've suggested, does that mean RSVP? And I got a very vague response back. So I think it would be very useful to actually try to define in the document, what do you mean by a TE-enabled application? And that may lead to some understanding about how difficult the interpretation of these two will be. The second is, I've talked about backwards compatibility issues, and the general response seems to be like, well, if you did this in the past, you were wrong. And so there are no backwards compatibility issues. And if you were to rewind, say, 2 years ago, before these extensions existed, I think you would have seen no problem at all with using the SRLG information for remote LFA. So I think the backwards compatibility issues should be taken very seriously. It may be a problem to solve, but simply saying that backwards compatibility is not an issue is not going to be productive.
So if you use TED to compute non-traffic engineering, to use it for non-traffic engineering application, you can continue doing so. Nothing prevents you. The information is still going to be populated by TE LSAs next to non-TE.
Jean-Marie, Orange. Well, I kind of agree with the previous comment. As far as I know, when we need SRD information in our IGP, we enable TE if it's the way it's implemented in our deployed implementations. I don't see the need to tweak the original specification to do it otherwise. If TE means that the thing you need to enable to have SRGs, then you enable TE. And maybe it's because it's here, maybe just a guess, right, on AC comments, because it cares more enabling TE for OSPF people than it is for ISIS people. Maybe?
So again, going back to backwards compatibility, it's not going to break your network. You can still use, since TE is enabled, you can still use TET in order to look into SRLGs. However, for people who are looking to do so, there's going to be a way to do it cleanly without enabling TE, which has nothing to do with a lot of information.
Yeah, yes, I got your answer. I just don't see why it's cleaner to do this new thing.
So our assumption, if you don't need TE, don't enable it, while you might need some of this information for non-TE application.
Hi, Aaliyah Atlas, no hats. I'm curious how many people see this as a problem. I know that when we did LFA, it talks all about SRLGs. It doesn't have a reference to the extensions, but clearly that was the only place you could get SRLG stuff. Now, I don't have any strong reason to believe that very many people have implemented the SRLG aspects, but I think certainly at that time, others, anyone who was talking about it assumed that you would just get the SRLG information from the TE topology. I do share the concerns about migrations or changes, or I have a very hard time hearing you come in and say, well, this is a protocol problem, so we can ignore the but we'll just fix it and there's not an operational aspect if it were to happen. I'd like to have our focus be the other direction, solving the operational
This is exactly the point.
problems.
There's no intrusive migration. You can continue using TET if you did so before. The information is still there.
The information is still flooded and there until you have a difference of interpretation about some devices flooding it this way because it's the new correct way, and some that are flooding it the old way. And then we have interoperability problems because one's not listening to the other. I'm not saying it's not solvable, but I'm not convinced it's a problem. And I'd really like to get perspective from other people to hear that it is a problem and that it's that there is operational pain from having to turn TE on, for instance, in order to flood this information. I mean, if we hear from operators that they're actually having problems, or people who want to proxy for operators, that's a different story. But until then, again, no hats. I have a hard time believing that it desperately needs solving.
Understood. So it would be great to hear from operators, people we are doing it for, whether you think it's useful, solves problem. And again, since IP faster router technologies like LFA, remote LFA become more and more popular, there are going to be more and more people willing to make use of it, and they'll have ability to do it cleanly without enabling traffic engineering in IGPs.
Especially operators using OSPF.
Go ahead. I didn't want to.
Jean-Marie again. Trying to rephrase it, is it just a way to expand the T package into sub-options to enable them separately, or is it more than that?
No, it's moving this information out of that. So you don't need to enable traffic engineering.
Isn't it implementation specific? What do you mean out of that?
No,
out of TD?
Out of TD database. It is.
What do you define as TED?
What is so the information distributed?
Back to the previous comment again. Not sure we have this exact same definitions on the starting point. So
Yeah, so I think draft would greatly benefit from exact definition of T application. We will work on it.
Yeah.
But the leaving aside definition, it gives you ability to distribute information which previously could be only distributed through T extensions.
Right.
Now you get ability to distribute information without having configuring traffic engineering.
Well, let me just say something. I'm a co-author as well. I didn't write it, but I will participate in this discussion of the backward compatibility. I think the thing is that with all the stuff being put into prefix linked attributes, you're going to have those anyway. So this would allow you to do it in 2 LSAs, since we already got one disjoint piece of information, rather than having it in 3 places now. So that was
segment routing is the best example.
That was one reason why we wanted to consolidate it in the prefix link attributes and the OSPF v3 extended LSAs.
Chris Bowers, Juniper. Not sure if I exactly understood that, but I mean, one way forward is if the motivation is we are adding lots of new stuff, you draw a line in the sand and say, okay, anything moving forward goes here with this new definition, but stuff that has been defined for many years and has been assumed to be in that place, leave it where it is.
No, you can't say that, because all new stuff, the TE stuff, has to continue to go in the TE.
We are not moving out.
I mean, there is a difference, I think, between TE and non-TE, because typically the TE stuff goes to a different can go to a different entity to compute the path, whereas the other stuff doesn't necessarily.
I see taking SRLG as a good example. If you now move it to potentially 2 places to be advertised, one for TE applications and one for non-TE applications, then the safest thing to do is to avoid backwards compatibility is advertise it in both places at all times.
That's exactly the idea.
In which case, moving it in the first place makes no sense.
Well, you wouldn't advertise it if you're doing it. You have TE enabled. If you're advertising in the first place, you have TE enabled on the link already.
If you don't enable T, you won't advertise.
You won't have it advertised
in T topology, right?
Right.
In this case, you don't need to enable T to advertise to make it consumable for non-T application.
So let's wait for another version of the draft with an actual definition of what TE enabled is, because I assume that means RSVP, but I couldn't get a clear answer on that.
To a large degree, yes.
Okay. Yeah. I mean, it's obvious we need more discussion on this. It's not definitely no consensus here.
So again, I think we presented 2 options. One is to continue doing what we've been doing for the last 15 years. Another one to make it better. We have obvious bias to second opinion because we propose to use it. However, again, we are asking you, working group, to your opinion and what should we do?
Thanks, Jim. Yeah, thanks. Okay. This prefix link tags, this seems like an obvious thing to do, and I've had this draft for a while, but the agendas have been sort of full at the last couple IETFs, so I didn't have any real burning need to present it. But this one, I said, okay, now I'm going to present this one, and I did a cleanup on the draft and put together the presentation. So right now, you know, what this does, it just allows you to advertise one or more administrative tags and associate it with a prefix or link, either in OSPF v3 or v2. It makes use of, like I said, in the direction we're going, it makes use of the extended, the TLB extensions in the 2 protocols. A lot of it, I looked very closely at RFC 5150, the ISIS draft. So hopefully even the ISGIS guys will like this one. The one, I don't count on it, but the one thing I didn't do is I had the 64-bit tags in as well, but I looked and nobody had implemented it. a matter of fact, when we say multiple tags, the multiple tags people had implemented were a very small number, like 2 or 3. It was nobody had implemented like 20 tags or anything like that. So I just moved this to an appendix. I think the original, this was way back from the days when people were thinking you still might put BGP routes in the IGP, and it would be, for an extended community. But that's just not a use case. So I did not put the 64-bit tags in. And what we can, hopefully none of these are too controversial. I'm going to talk to whether or not a use case falls into the use of these tags. This is one of the things that for the node tag draft, the use cases were actually as controversial in the final discussions as the extension itself. But I think most of these are pretty straightforward. We could do it, use all these, for instance, for controlling redistribution. Right now, we can only do it for external routes because that's the only place you can put a tag, or selecting prefixes either for protection or for prioritization. And there, like I said, there's always a fine line. If it's something, it may be something, now that we have TLVs, it may be something you don't want to use a tag for. If it's something really that needs to be standardized, you could have a specific TLV just for that purpose. For the OSPF-v2 encoding, we allow it both for the links and the prefixes, just using the opaque LSAs, and it's simply a list of 1 or more 32-bit admin tags. OSPF-v3, I took advantage of the extended LSAs, and you can see for all the ones where you have prefixes, you can advertise a prefix LSA, and all the ones that are, and the router, the only place you can have a link again is the router LSA and the router link TLV and extended LSAs. It's the same tags. Okay, this is the key one. The ABRs and NSA translators must propagate tags across area boundaries. So if you're generating summaries, you should propagate the tags. The number of tags depends on how many tags you support. I'm not going to, you don't have to support more tags than the router supports. So if it only supports 3 tags and you end up with 5, you only have to propagate the number you support. The tags should be configurable on area ranges now. And again, OSPF-v3 must support 1 prefix or link tag. And for ECMP prefixes, you can propagate, you should propagate the tags from the contributing paths if you have different prefixes, if you support multiple tags. Now these, when we discuss this, these are all subject to negotiation or working group consensus. And, oh, I thought I had one more slide. Oh, well, the other thing that I was going to say, I must not have uploaded, I thought I did recently. The one other operational consideration is for the NSA and external LSAs, the first tag, you must use the existing mechanism. So, we have a tag field in NSA, LSAs, and external. So for your first tag, you must use that just for backward compatibility. Anyway, next step, more discussion on the list of this. Has anybody read this? Jeff, okay. Okay, so Peter or myself will, I don't know, we'll probably be discussing the other one so much. This may take a while before we get to this one. Okay, and that's it. I mean, that's the last presentation. Anybody else have anything? I want to thank Huawei for providing the remote participation. In India, in Bangalore. Okay. Thanks. And we're going to finish early for now. Oh. Oh yeah, I guess you could. Well, but nobody supports it in their ribs. I don't.
I'm just thinking that it's not uncommon to do this. From
It's not that common.
Not that common, but it's not uncommon.
It's uncommon.
I'm sure no, I don't know.
Ah, yes, you could. Yeah. You could. I could see that. I could see that. Well, yes. Yeah. Well, we have. Well, we. It was kind of that. I did have it sitting there. Just one. It's clear if there's a router, you have the other link. There's nothing. If there's nothing on the other end, you don't have an adjacency. Right. I don't know how you. You could get it if there was OSPF on the interface. You get it from the other guy. Okay. If there's OSPF on there, you can find it. Because the other guy, the guy on the other end of the link advertises it in the link there. Of the adjacency. Okay, yes.
It's past IESG review. It was discussed, but it seemed to be more that he was a little frustrated.